So today we're going to talk about percent yield. We're going to talk about how to calculate the theoretical amount of a product that is formed, and this will be the same process as calculating a limiting reagent like we did with other stoichiometric conversions. So whenever we talk about percent yield, what we're actually going to look at is we want to see how much product was formed and then how much product could be formed in theory. So if this reaction worked to 100% efficiency, what would the output be? How much product would we form? Well, not all reactions work with 100% efficiency. So what we need to do is we need to try to calculate the percent yield. We calculate the percent yield by taking the actual amount of product that is formed divided by your theoretical amount of product. So this actual amount, this has to be given to you, or it might have been measured in a laboratory setting. So let's go ahead and take a look at an example. So the actual amount of product in a reaction is 39.7 grams. We calculated the theoretical yield of 65.6 grams. What is the percent yield of this product? So to calculate the percent yield, we are going to take the actual amount divided by the theoretical yield. So in this case, the actual amount is 39.7 grams. The theoretical yield was given to us in this particular example, which was 65.6 grams. And then we're going to go through and multiply that by 100. And whenever we plug and chug this should be 60.5%. So the percent yield is 60.5% for this particular reaction. Okay, so this is the simplest example that we could have whenever we're given the actual and theoretical amount. So let's go ahead and try a problem now where the theoretical amount is not given to us. So in this particular problem, we want to know what is the percent yield in the following reaction if we have 5.50 grams of hydrogen and this reacts with nitrogen to form 20.4 grams of ammonia. Okay, so notice that hydrogen is a reactant and we're given the initial amount of this. And then the other piece of information that's given, the 20.4 grams of ammonia, because of how this is written, this is the actual amount. So how much ammonia was actually formed. So what we need to do is we need to try to figure out what is the theoretical yield of ammonia. So the first step to calculate the theoretical yield is just to do a stoichiometric conversion. Let's go ahead and start with that. So in this case, we start with 5.50 grams of hydrogen. So we'll need to start by converting that to moles. So we'll divide by the molecular weight of hydrogen. Okay, so now that we have it in moles of hydrogen, we need to use a mole-to-mole ratio to figure out how many moles of ammonia we have. So from our balanced chemical equation, we have 2 moles of ammonia for every 3 moles of hydrogen. And now since we're looking for a percent yield with respect to mass, we need to go ahead and convert from moles of ammonia to grams of ammonia. So we'll use the molecular weight of ammonia, which is 17.04 grams over 1 mole of ammonia. And whenever we plug this into our calculator, what we'll find is we get 30.9 grams of ammonia. And this is our theoretical yield. So if we want to calculate the percent yield, what we're going to do is we're going to take, just like in the previous example, our actual yield, which was given to us, 20.4 grams, divided by our theoretical yield. So we'll take percent yield is equal to 20.4 grams divided by 30.9 grams. Multiply that by 100, and we will get that the percent yield is 66.0%. So this is how you will go through and find the percent yield. In many cases, you might be given information or starting amounts for both reactants. and then you'd have to figure out which one of the reactants is the limiting reagent, and that will tell you the theoretical yield. But in this particular example, how it's written, it is assumed that the nitrogen is in excess. So hydrogen is our limiting reagent. But if you were given a mass amount for both hydrogen and nitrogen, you'd go through, calculate which one is the limiting reagent, and that limiting reagent, that would tell you the theoretical yield. All right, so that's all there is to calculating the percent yield. Hope this helps.